Let's get started. So, set this up the right way now. I gotta reset my brain. Hold on. So just a quick tip, a couple things. First, just a reminder, I'll remind you the first few lectures for the first 3 weeks. I've been watching the Discord channel, the lecture channel, and the Discord server. So if you have questions, feel free to ask there, or the old-fashioned raise your hand. That works just as well also. But I'll watch that during lecture, so when I'm watching my phone and talking to my phone, just know that's what I'm doing. I'm interacting with at least one of your classmates and answering questions. Next, on the course website, once you read the syllabus, and I basically read you the syllabus on Monday, you're good with everything in there. These do collapse. I like showing this off in the first lecture because I've always had students like halfway through the semester say, oh, I didn't know you could do that, but I'm scrolling past the syllabus every single time I go to the course website. These do collapse. And then as we go through each week, you can collapse each week so you don't have a lot of scrolling to go through to get to the relevant content. We're on week 1, so we're not really going to be able to do that too much quite yet. And then the slides, you'll see me do this at the beginning of each lecture. I'll download the slides right from the course website. And then when I download it, you'll see it's going to say, you've already downloaded this 2 other times. I'm still going to do that most times. Just as mostly a sanity check for myself, but to make sure that what I'm presenting up here is exactly what you have access to on the course website. I don't want my slides I'm presenting with to be out of sync with what you have at all. So just to make sure, usually to make sure to myself, prove to myself that I didn't mess anything up, which I do sometimes, that I'll have those same exact slides that I'll do right before lecture. And sometimes the slides won't be what I expect, and I'll say, oh crap, I forgot to update the website, and then I'll update the website real quick. That shouldn't happen in this section because I have another 116 section right before this, but I'll still usually do that. Out of force of habit, I'll download them again. But I want what you have to be the same as what I have. And, I forgot to mention this in the other section. I'll have to remember on Friday. But there are 2 116 sections. I teach them back to back, the hour before this, and then this section as well. And the other one is in I'm in Cook right now, right? Cook 121. They're so confused. I always get these ones confused. Hofstadter 114. The other one is in Hofstadter 114. I don't care which one you go to. If you want to go to the other one, if that fits better in your schedule, or if that can end your day earlier, is usually what students like to do. By all means, go to the other one. The only time I would say no to anyone for that is if one of the lecture rooms gets too full. There's literally not enough seats. At that point, I would have to ask anyone who's not registered for that section to go to their own section. That has never been an issue before, so I don't expect it to be an issue, especially this is a hard course. Like the class thins out as we go anyway, and the rooms aren't even full. The registration for this section, for example, this is probably at least close to everybody. The room has much more capacity than the registration. I think there's 100 of you registered. This is not all relevant information. I don't know where the fire code thing is back there, but I can't read it. But this room handles like 180, I think. Anyway, let's get on with it. We got a lot to talk about. We don't have time for more announcements. So let's start talking about 116 stuff. I say that, but for the first 2 weeks until week 3, Monday, most of this is basically 115 content and an introduction to Java. So I'm going to very quickly go through all the 115 stuff with the assumption that you already know all of the concepts, that you know how to do all this stuff. But I want to go through that stuff focusing on how Java works and all the differences from Python or JavaScript to Java. I'll do that focus for those of you who took 115 here. But introducing all the new Java stuff, even if you don't know Python or JavaScript, it'll still be applicable. And of course, if you already know Java, you're ahead of the game these first few weeks. So it's going to be fast. Especially the first 3 lectures, and then next Friday, it is a catch-up day, so I can show examples and slow down a little bit. And then starting week 3, things can slow down as we get into our first 116 topic proper, which is unit testing. But these first few lectures will go fast. So when today's lecture is going very fast, don't panic. I think most of the topics in these first few lectures are easy to digest. They're pretty simple, straightforward topics, but there's a lot of them, and it's going to go quick. So just giving that warning, with that warning out there, let's do this. So this is our very first Java program. Very simple, the simplest Java program I can possibly think of. It just prints hello Java to the screen, and it's still pretty complex. There's a lot of stuff going on the screen at this point. So let's break this down and talk about all of these pieces, which is about as simple as a Java program can get. The only thing you could argue is you could delete the package declaration and put this code in the default package, which is never recommended. Don't use the default package, but for those of you who know what that means. But this is as simple as we can get a viable Java program, a good Java program. So package declaration. Let's just break this down one piece at a time. Package declaration, you can think of this synonymous with the directory structure, the directory of this code, or there are students I know who get confused when I say directory. Directory and folder I use synonymously. So this will be in the week 1 folder in your project structure. All of your code in Java, at least the setup we're going to use, is going to be in a directory called src, short for source, which itself is short for source code. That's where all of our code is going to go in this src directory. And then within that directory, the package is going to specify the subdirectory. So this code in package week 1, the package is week 1, means it's going to be in a directory source/week 1. That's where this code is going to be saved. Next, we have the class name. We're going to declare a class. And why would we declare a class? First of all, everything in Java, all the code you write has to be in a class. It's a Java thing. Everything's got to be in a class. There are a few somewhat exceptions that we'll see later on in the semester. But for the most part, everything's got to be in a class. There are different types of entities. There's class, interface, abstract class. So technically, if it's defined in an interface, but everything's in a class. So we have to have a class to contain our code as a container for our code. The class name has to match the file name for this code. Java will enforce this. Java will enforce the package matching the directory. Java will enforce the class name matching the file name. So class hello world has to be in a file named helloworld.java. So putting it all together, the full path for this code right here has to be source/week1/helloworld.java. So if you're going into the examples repo, you want to find this code, that's exactly where you're going to find it, and Java will enforce that. Java will make sure this code is right there, which is nice because if you're looking at the code, you know exactly where this code exists, where it came from. But the other way around, if you're looking at the directory structure and you see this file named helloworld.java in the directory week 1, you know that that's defining a class named helloworld, and it's in the package week 1. So this is some structure to our programs, to our projects, that Java will enforce. We can't just throw our code all over the place and mix it up in weird ways. This does imply that your files can only have one class per file, no, I don't even want to go down that one. Which lecture should I watch in 115 to catch up quickly? I would any of them related to the topics that I mentioned last time. Would be anything about variables, expressions, functions, loops, conditionals, and data structures, and file I/O. All of modules, if you're looking at the structure of the course, all of modules 1 and 2 would definitely be your foundation. And then I think file I/O is the only topic that's outside of modules 1 and 2. I think it's in module 3. Starting with the beginning of the course, and anything that you do know, obviously you can skip over, but just making sure you know the first half of the course at a minimum. All right, and then the main method. This thing is, like most things in Java, way more complicated than it has to be. So public static void main string array args. Let's talk about this. Let's break this down and talk about what all this is. So the goal here, what we're trying to do is create an entry point for our program. And we do that by declaring a main method. The main method is our way of telling Java, this is where my program starts. This is where you should start running code. So if I have a main method that looks just like this, I'm saying, Java, run this line of code when I run this file. So when I run the hello world class, it's going to actually run the main method defined in that class. The main method has to look exactly like this, or else Java's not going to know where to start your program. So let's break this down. Aside from public, I'll talk about that on the next slide. Let's break this down. Static, and I'm going to give very, very brief explanations of each one of these keywords as we go throughout the semester. And I'd say by the end of week 4, you'll know pretty well in depth all of these keywords, what they all mean. We'll revisit each one and you'll know them all in depth in a few weeks. For now, I just want to give a very brief explanation just to get us off the ground so we can not be too scared of all of these keywords on here. So static, this means that we can call this method without any extra steps. And I'm using the word method, so I gotta explain that one too. In 1.15, you heard function, function, function all the time. In Java, I'm gonna call them methods. Same thing. When I say method, you hear function, I'm not gonna be mad at all. There are technical differences between the two, and we will actually explore that later in the semester. But for now, if you just hear function when I say method and treat them as synonyms, perfectly okay with that. The technical difference is whenever you have a function, or what would be a function that's defined inside of a class, that's called a method. It's a function that's part of a class. And since all of your code in Java is contained within classes, guess what Java has? Methods. All methods. Java doesn't have functions because you can't declare any function outside of a class. Everything's in a class. So in Java, they're methods. If that seems needlessly confusing, I agree. But I feel part of my job is to be at least mostly correct when I'm saying it. So I'll try to say method. I'll slip up a few times this semester, I'm sure. But I'll try to stick with method every time I say it. All right, so static, we can call the method without any extra steps. Now those extra steps we'll see in week 4 is creating an object and then calling the method through that object. Static means we ain't got to do any of that. We don't have to worry about what those things are yet, which is good because I don't want to worry about what those things are yet. Not until week 4 when we are ready to dive into that topic. So static means we can use this code easier. Void means this method doesn't return anything. The main method isn't supposed to return anything. It's our top level entry point for the program. There's no need for it to return anything to like the operating system or anything. It doesn't need to talk to it. So it returns void. I guess it does in C++ if you're coming from C++. We don't return ints. We don't return anything from a main method. And then the method name itself needs to be exactly main, all lowercase, M-A-I-N. If your main method is not named main, say you put a capital M there, Java's not going to know that it's meant to be a main method and it's not going to run it. And then string array. So the type of the parameter is an array of strings. And then the one thing that we can change, the one thing that doesn't have to be exact is args. This is a variable name, so we can name it whatever we want, as opposed to the method name. I guess that is confusing too. But by convention, we usually name this args. If you don't want to worry about this part at all, string array of args, that's not something we're going to use in CSE 116. This is if you're calling your method through, or your program, through the command line and giving it command line arguments. So this is where those arguments would go. Not something we're going to do in 116, so we're not going to worry about it. But if that's not there, Java's not going to treat this as a main method. So we still have to say string array args, even though we're not going to use that variable, that method, that parameter at all. And then public means that we can access this code from anywhere. There's different access modifiers in Java that restrict who can use the code that we're writing. Public means anybody from anywhere who has access to this code, they're allowed to call these methods. Your main method has to be public, so we're going to make it public. So with all of that, and it'll take weeks and lectures to fully understand all of those keywords. I know I went through them quick, but if you think that's confusing, this is exactly why we don't use Java in 1.15. Day one of 1.16, or day one of content at least, of 1.16, this ain't so bad. I don't think that's too overwhelming. You already went through a semester of programming, so you're not going to get scared away that easy. But if this was day one of content for 1.15, that's a lot. So we don't use Java in 1.15, but you're ready for it in 1.16. Yep.
In what case do we use private?
So we're going to use private for what's called instance variables in our classes. When we create objects, this is getting way beyond it, so if y'all want to tune out for a few seconds, I won't blame you. But when we create objects, they're going to have variables contained within them, and we don't want anybody being able to change those variables directly from outside of the class. So we're going to restrict access to those variables, but we're still going to have all our methods be public, and then people have to call the methods to access those variables. So that'll be the one case that we're going to see in 1.16. The deeper answer is you don't. A lot of languages, like Python, didn't even have access modifiers. Everything's just public forever. My argument for that is, who are you protecting your code from? Like, do you not trust the other people on your team that they're going to go in and mess up your code? I mean, that's what Java says. So if you don't trust your teammates, then use Java. But if you trust your teammates, you can use a different language that doesn't even have access modifiers. Whole languages thought this wasn't important. Yeah.
Didn't the CSE 115 course get changed like last year or something like that?
Mm-hmm. Yeah, this semester there are some big differences to the course. So there's no more JavaScript, no more web stuff. I think they cut the security stuff as well. So either fortunately or unfortunately, you were the last class to go through the old 115. And then they're going to have more of a focus on all of the other topics, all the fundamental topics. They're going to go in depth further with those, including memory diagrams. They're doing memory diagrams this semester, which we'll see by the end of this lecture. They're big in 1.16, and we're moving those to 1.15 as well. So not too many fundamental changes, but the big pain points of the course, which was the web stuff, which I personally liked. I know a lot of you don't want to hear that, but that was a big pain point for students, so we got rid of that. Would you rather not have done that?
I'd rather let them suffer. It's like gladiators. You gotta go through.
I had to suffer. You had to suffer. Yes. There's a really hard 1.16 assignment, a genetic algorithm that I always used to run in 1.16, and it was hell. Everybody hated it. But whenever I asked the class, like, should I keep doing this? They always said, yeah, you should keep doing it. We had to do it. They got to do it. So I did finally cut it, so you don't have to go through that one. But especially the TAs, they're like, no, they have to suffer. Then those TAs graduated. I'm like, you know what? I'm getting rid of this assignment. I hate it. But yeah, us students always have that attitude. I had to suffer, you had to suffer. I get it. All right, so yeah, that's why we don't do this in 1.15. That's a lot. So the main method has to be like this: public static void main string array, and then args, you could change the variable name if you were so inclined. But everything else has to be exact character for character, or else Java won't treat it as a main method. The good thing is you don't have to memorize this. You don't have to memorize public static void main like I always had to when I was a student. We're going to use something called IntelliJ. That's going to be our IDE for this course. We're not using online IDEs like you did in 1.15. You're going to install IntelliJ on your machine and then use that as your development environment. And in IntelliJ, if you type main and hit enter, it's going to put all this there for you with the right format. Yeah.
If you already have an IDE, do you have to use IntelliJ?
Nope.
Okay.
You can use whatever you want. So IntelliJ is the officially endorsed IDE for the course. So if you have IDE issues and you're using IntelliJ, you come to office hours, we're going to help you out. You can use whatever you want. If you have something else set up, a lot of students like to use VS Code, perfectly fine. But you have to know how to use VS Code. If you come with VS Code specific issues to office hours, we're not going to help you. We're going to say use IntelliJ. If you're using something else, you got to know how to use it. So if you want to use, I presume VS Code. If you want to use VS Code, go for it. Not going to stop you. Yep.
I just installed
Yeah, the IntelliSense
I don't know if
plugin.
but
Oh, that's something you'll have to. If you're using IntelliJ, I'll help you out. If you're installing a plugin on VS Code, you're on your own. So that's exactly a question that I won't answer. But I think there is. I'll answer. Give it a brief answer. I think there's an IntelliSense plugin for VS Code that gives you like the code completion tools and a lot of the things that help you in IntelliJ. But I've never set that up, and I'm not going to help with it. Should we trust Edward Snowden? Ooh, man, hit me with the hard questions right away. I don't know. I wouldn't trust him with your secrets, that's for sure. But if he's telling you secrets, I'd probably trust it and believe it, right? I don't know. That's a tough one. That's something you got to answer by yourself. All right, so main, if you just type main, it'll give you all that for you. And I'm not big on memorization. I'm never going to quiz you and say, what's the proper structure of a main method? I'm not going to do that. The IDE will do it for us, so don't bother. And then also needlessly complex is printing to the screen. In Python, this whole program would just be print hello Python, and that's it. Nothing else, one single line, very straightforward. But even when we get to the point where we can write Java code, system with a capital S, dot out with a lowercase o, dot println with a lowercase p and a lowercase l, and then the string that you want to print to the screen. This is how we print to the screen, system.out.println. And if you're in IntelliJ and you don't feel like typing this, I can't even remember the last time I typed out system.out.println. Just do s out and hit enter, and it'll print that whole thing for you. So it can really cut down your characters. For what it's worth, S out is fewer characters than print. So with an IDE, we can get these shortcuts and really start saving some time. And every statement in Java ends in a semicolon, for what it's worth. I don't have much to say about this. It's just a fact of life. This used to be a really big pain point. It used to really suck. C++ or Java, remembering your semicolons and getting all kinds of errors and stuff. These days, your IDE is just going to squiggle the end of your line in red and say, looks like you forgot a semicolon right here, and then you just go, oh yeah, I did, and then you add your semicolon. So it's not that big of a deal these days with the IDEs, all the tools that we have to help us write code. But that is a thing. If you see that error and says expected semicolon at the end of the statement, it just means you forgot your semicolon, add that semicolon in. And I think it's on one of my slides. I forgot to mention it last lecture, so let me not forget now. Anything within the braces is going to be part of the definition of a thing. It'll be a code block. So inside these braces is the class. Inside these braces is the main method. And indentation does not matter. So Java's going to look for those braces, and that's it. Doesn't care about any indentation. Like Python did. Python cares about indentation. And even if you want to have multiple statements on a single line, separate them by semicolons, and you can do that too. There's no good reason to do that, but you're allowed to. Okay, any questions on that example before we get to the next one? You make a new method inside the main method in Java. IDTS. You make a new method inside the main method in Java. The short answer is no, but the longer answer is yes, you can. But it's more complicated than anything we have to do in this class. Really, you would just create another method outside the main method like this, and then call those methods from the main method. But you can kind of do it in, especially in later versions of Java, but it kind of doesn't. But it gives you what we call syntactical sugar, where it looks like you are, but you're actually defining an anonymous class. It's stuff we don't have to talk about. So with recursion, you're calling the method that you're defining, but you're not defining a new method. You're just calling the method. Like if in multiply by 2, I called the method multiply by 2, that'd be recursion, but it's not defining a method in a method. It's using the method that you're defining, which is a subtle difference, but it does change the behavior. Okay, so let's talk about this example. So when I go through this example, and this will be true with Friday and Wednesday as well, there's not really going to be any new concepts right away, but there's a lot of new Java-specific stuff. Actually, I'd argue that there's a new concept starting on the next slide. There's a lot of Java-specific stuff. So I'm not going to spend time talking about this is what a method is, this is how you call a method, parameter lists and argument lists. I assume you know all that kind of stuff. What I'm going to do is focus on the Java-specific things, the new Java stuff. The first new, big, huge Java thing is strong typing. Java is a strongly typed language. If you did do Java before, this ain't new to you. If you came from C++ and transferred 1.15 in, this isn't new to you. But the majority of you are coming from 1.15, I assume anyway. The majority of you are coming from 1.15 with Python and JavaScript, where this was not a thing, so this is the brand new thing. And the first, biggest thing that you have to care about in Java. And we will have to care about this all semester. It's a huge part of Java or any strongly typed language. Strong typing takes some adjusting. So strong typing means that every single variable you declare must have a type, and that variable, for as long as it exists, can only ever store values of that type. So you really have to track your types and know what your types are when you're coding in Java. This isn't necessarily true in Python or JavaScript. You can lose track of your types. You can reuse a variable and just put a different type in it, type value in it, and it'll just change. It'll just store that. It'll let you do whatever you want. Java is a bit more strict. If I say this variable num is of type double, it can only ever store a double. And if later on in my code I try to say num equals the string hello, that's going to be an error. Java's going to say you're trying to store a string in a variable of type double. That's not allowed. It's not going to let you do that. Can't do it. So we're not just declaring variables, we're declaring variables and specifying their type. So I'm not just saying declare a variable named num and assign it the value 2.4. I'm assigning a variable of type double named num and assigning it the value 2.4. And luckily 2.4 is a valid double, so I can store that in the variable num. Defining a method, most of it's the same as any language, so I'll skip over a lot of details. First, public static. For the first few weeks, all of our methods are going to be public static. The main method we already saw was public static. These methods are all public static. They're going to be public static. So public, just a reminder, you can access it from anywhere. Static means we can use the method without doing extra work, which would be creating a new object of the type matching the class and then calling the method through that object. We don't know what any of that means yet, so I'm just going to say static means we don't have to do extra stuff to call this thing. So everything's going to be public static. So I'm going to stop talking about public static after this example. They're just all going to be public static for the first 3 weeks until we get to week 4 and we're talking about objects. The next part is the return type. So every method has to have a return type. So not only your variables, every variable has to have a type, but every method has to have a return type that's, as the name implies, going to be the type that that method returns. And when you specify a return type for your method, this is a contract you're signing with Java. You're signing a completely 100% binding contract with Java that says, I'm going to return this type. When I return something, 100% of the time when this method is called, I will return a value of type double. Has to happen, and Java will enforce that. Java will force you to return that type. If you don't return that type, what's Java going to do? Nothing. It's going to say, you broke the contract, I'm not running your code. You can't even hold your word that you're going to return a double, not going to run your code. Name of the method, and then our parameter list. Parameters are variables. Every variable has to have a type, so our parameters have to have types. We saw this with the main method already. Args is of type string array. We don't have to worry about how arrays work in Java. We're actually going to avoid arrays in Java. We're going to use array lists instead. But the type is a string array here. Just like this one, input is of type double. So this method, I would say, this method named multiply by 2 takes as a parameter a double and returns a double. And I guess it's public static. So that's how I would describe this method header. So when I call this method, I have to give it a double as its parameter. And then finally, the body of the method, anything between the braces, is going to be the code that's executed when the method is called. And here I'm declaring another variable, naming it x. It's of type double. And it's going to have the value input, whatever is stored in this variable, times 2. And then return x. So when I return a value, Java is going to make sure that that value's type matches the return type. So this is where that return type is going to be enforced. I'm returning x. X is of type double. My return type is double. Those match, so Java's going to be happy. I satisfied that contract. There's no way to make it through this method without hitting a return statement that returns the result of an expression that resolves to a value of type double. Can't happen any other way because it's a really simple method. It's just 2 lines. We're going to hit this return statement and return a double. So the return type has to match whatever we're actually returning. And this will get a little more complex when we talk about conditionals. If I have multiple paths to multiple return statements, every single path through that method has to result in returning a value matching the return type. Oh, here's my slide where I say indentation does not matter. And on the other side of things, we're going to take advantage of that contract. So we're calling the method multiply by 2. We're going to give it a double to match the type of its parameter. And then we're going to take advantage of the fact that it will, guaranteed 100%, it's going to return a value of type double. So since multiply by 2 returns a value of type double, I know this expression resolves to a double, and then I can assign it safely to a variable of type double. So num is a variable of type double. I assign it the return value of a method that returns a double. That's going to be a valid assignment. So if Java wasn't so strict about the typing of our return type and let this method return a string, for example, then this might be an invalid assignment because we'll have a string assigned to a variable of type double. Wouldn't be allowed. Program doesn't run. So since it is enforcing everything, we can take advantage of that when we're calling methods. And when we're defining methods, we have to satisfy that contract. Yep.
Can you switch between types at all? Or like,
Yes. Most of the time we don't want to. So the question, can we switch between types? Most of the time we don't really want to. The one big exception is converting ints to doubles. If I call this method, for example, with an int as its input, it'll automatically be switched to a double. We haven't talked about those types yet, but we will on the next slide pretty soon here. An int can't have a decimal portion, a double can. So any int can be represented as a double. So Java will just automatically switch that for us. We can change doubles. I'm getting a little far. The short answer is most of the time we don't want to. But technically we do have the power to in a lot of cases. But we usually don't want to. Yeah.
For example, if you perform matching of like a whole integer division or like double division, you might convert it, right? Like,
Yes. Yeah.
that would be a new variable though.
Yeah. So the evaluation of the expression will create a new value, and then you could store that in a new variable. But the type of the result might be different depending on the types of the arguments. Yes. And we'll see that a little bit on the next example. Yep.
If I'm remembering correctly, if we do division or multiplication with just 2 integers, does it convert it into a double automatically, or do you also have to perform some operation with a double?
It'll do integer division. That's actually part of my next example, but it'll do integer division. It'll truncate the decimal portion and return an int. It won't automatically convert it to a double. Like some languages will automatically convert it. Java will not. Java will do integer division. But yeah, if one of them is a double or you change one of them to a double, then yes, you'll get the floating point value. So with return types, sometimes we don't want to return anything. Here's a method that I don't want to return anything. I want to call it just for what's called its side effects, which the side effect for this method is printing something to the screen. I want to call this to print something to the screen. It's not computing anything for me that needs to be returned. I'm not storing anything after I call the method. I'm just calling it for that side effect. And you wouldn't really do this. This method is called why, because why would you ever do this? There's no reason for you to ever do this unless you need a lecture example for a void method without getting too complex. It's the only reason we would do this. So this method has a side effect, doesn't return any value. So we give it a return type of void, which means this method don't return anything, don't have a return statement anywhere in this method, and Java's okay with that because I didn't really sign any contract. The contract I signed is don't worry about it. So Java's going to say, yeah, I'm not worried about it. You're not going to return anything. Let's not worry about it. And then I can't, I'm not going to assign this expression to anything because there's no value that's being resolved to. It does, I believe it resolves to null. I don't know. It resolves to something, but nothing useful. Then we get to the end of the main method. Once we hit the closing brace for the main method, program's over. Everything shuts down, and hopefully the program did what you wanted it to do, and you can go code something else. Okay, we got a little ahead, so let's talk about the stuff that I gave quick answers when the questions came, but I'll slow it down a little bit so we can all see what was going on, what we were talking about there. So Java's strongly typed, but in that last example where I'm talking about strong typing, the only type I used was double, and I didn't even explain what a double was. So let's talk about some common types. These are the 4 primary types that we're going to use for the first few weeks in Java until we start defining our own types. Then we're going to have tons of types, all kinds of types. But these are like the 4 basic types, I'll call them, that we're going to use throughout the semester. We'll add to this a little bit with, but we'll add a few more. I introduced this term basic type now. I don't know. I don't want to finish that sentence. But we'll add a lot more types, but not more basic types. The problem is I have string on there, so I can't say primitive because string's not a primitive. Kind of back myself in a corner with the vocab on that one. So let's just talk about these. So double, this is a numeric value that can have a decimal portion. So 2.4, that since it has a decimal portion, we're going to make that as a double. Doubles cannot be represented exactly in our computer, which is a great topic for week 3. For now, we'll just leave it at that. But these doubles can have decimal portions. So if I have a decimal portion, it's going to be a double. String is a sequence of characters, technically the type char for character. So this is a sequence of individual characters that are combined into a string. So notice that string does start with a capital S. This is what's called a class, and it's going to have a type, an object type. So it is different than our ones that start with lowercase letters, which are going to be our primitive types, which is something that we can explore the implications of not today. But notice that it is a capital S. If you want a string, it's a capital S. Your double, int, boolean, char, those are all lowercase letters. Start with lowercase letters. And string, it behaves how you would expect from 115. And then int, this is what we were talking about earlier. If I have an int, this has to be a whole number. It's another numeric value. Has to be a whole number. It cannot have a decimal portion. So we can't have a decimal portion on an int. So the question becomes, and by the way, our primitive or our literal types, if you don't put a decimal point, it's going to be an int. So my 6 and 4 here are both ints. My 2.4, since I put a decimal, that's going to be a double. Even if I put 6.0, that's going to be treated as a double and not an int. So if I wanted wanted one of these to be a double, I can put a 0.0 on there and it'll be a double. I didn't, so these are both going to be ints. And when you divide 2 ints, you're going to get what's called integer division, and the result will be an int. It has to be an int. But I expect the result of this to be 1.5. So what's going to happen? Java is going to just delete the decimal portion. That 0.5 is just going to erase it, give you just the whole number so it can be stored as an integer, and then I can store the integer 1 in the variable num1, or num2, sorry. So num2 is going to have the value 1, not 1.5. This is something we need to be aware of when we're writing code. Sometimes this is exactly the behavior we want. For example, if we're doing math and the result is going to be used as the indice of an array, then I want that to always be an integer. I don't want a half of an index. So sometimes we do want this behavior, but if we don't want this behavior, make sure you're not dividing two ints. Make sure at least one of your values is a double, because if even one of these is a double, the result will be a double. Even if it is a whole number, it'll be a 0.0. Question?
Is it truncated or is it floated?
Sorry, what?
The decimal portion, is it truncated or is it just rounded down?
It's truncated, but the result will be the same as a floor. So it's just absolutely erased, but effectively that takes the floor. So for example, if I have the integers 99 divided by 100, and I expect 0.99, and I would like that to be rounded because it's basically 1, no, Java's going to give you 0. And you're going to be off by almost an entire value in your computation. Yeah?
If you define the variable as int, you put 6.0 divided by 4, will it still return 1, or is it going to change the variable type to?
You're going to get a type mismatch, and it won't compile. It'll say expected double found int, and then it won't work. But if you do it the other way around, Java will automatically convert your ints to doubles if you did it the other way around, but it won't convert your double to an int. So even if I put 6.0 here, let's change it a little bit. If I put 8.0 divided by 4, the result's going to be 2.0, but as a double. So even though it's a whole number, I can't store that double in an int. So we do have to be a little aware of our ints versus our doubles when we're coding. Thought I saw another hand. Anyone? Okay. And then Booleans, I don't have anything to say about Booleans. For what it's worth, lowercase t, lowercase f, not capital. But they're Booleans. They behave the same in just about any language, for the most part. Okay. And we are not going to do much memory diagram. I'll go a little bit into this because I want to talk about memory diagrams. We might actually get to where we got in the other lecture. So I want to do memory diagrams early and often. We're going to see a lot of these things because this is what you'll do on your quizzes. Quizzes are a pretty challenging part of the course. I want a lot of examples out there. And hopefully you're doing a lot of practice. Students tend to not practice memory diagrams very much. Some students, the only memory diagrams they ever do is while they're taking the quizzes, and then they have to take the quizzes multiple times because you can't really do that. So I'm at least going to show a lot of examples, but it is up to you to get some practice with them. So let's do this. When we're doing a memory diagram, what we want to do is trace through the code and show exactly how the computer is going to interpret this code. Specifically, what's going to be stored in memory. To do this, we have a few different types of memory. The first is stack memory or stack space or the stack. I'll use all those interchangeably. The stack is divided into name and value, and this is where our variables are going to go. When a variable is declared, we're going to put the name of the variable and the value that that variable is storing on the stack. Next is the heap space or heap memory that I'll use interchangeably. The heap, we're not going to use yet. Once we start talking about data structures, we'll use the heap a little bit. And then when we get to objects in week 4, we're going to use the heap extensively. For now, we don't need to worry about the heap at all. But I want it on the memory diagram so we have the structure of how we're going to do these memory diagrams up there. And then finally, in out. There's no standardized place where this needs to be on the diagram. You can put it wherever you have room. Since I know we're not going to use the heap, I'm just going to use some of this physical space that would be used for the heap, use it for in out. But in out is not part of the heap at all. So when we print something, and this is where everything, I don't know if I said that, everything that we print to the screen, this is where you're going to write it. So when we print, I can print to the screen. We're going to put it in out. When we have a variable declaration, the name of the variable, the value it's storing, the name of the variable, the value it's storing, name of the variable, value it's storing. Don't forget about your integer division, name of the variable, value it's storing. And then whenever the machine needs to look up a value, it's not going to look at the code. What it does, because this is actually how the machine is going to do it, how Java is going to do this. It has a variable named num3 it needs to look up. It's going to look over here in this lookup table that it's created called the stack. Look for a variable named num3, look at the value it's storing, and use that in a replacement for that variable, and then print that to the screen. And my quick note, I got time for this. My quick note, strings. For those of you who do know this, I'll give a little asterisk here. Strings do technically go on the heap. In 116, we are going to put strings on the stack. I know it's wrong. It bugs me too, but it makes 116 a lot simpler. If we diagram strings the way they actually work, these diagrams get a lot more complex, and complex way early in the course. So we are going to put strings on the stack. I know it's wrong, but it's how we're going to do it to keep things a little more streamlined in 116. And this is exactly where we got in the other lecture. So I'm going to stop there, but we do have our first lecture question of this semester. Yay, our first of many. So for lecture questions, go to Autolab. Autolab is active. The roster is uploaded. If anyone has issues, come talk to me. We'll get you all set up. Lecture question for August 30th, and you'll see a multiple choice form for this question. For this question right here. So I'll do lecture questions at the end of each lecture. Once you answer the question, you're free to go. Have a great day, and I'll see you Friday. What's that?
Is it like it's saying submit programming assignments, right? I'm not
It's under lecture questions. So there's